If you'd like the real story behind this finding, it was a big surprise.
This spring, Aidan presented his honors research on green crabs at the annual Benthic Ecology meeting and won the award for Best Undergraduate Student Talk.
He's providing a lot of information to people who are thinking about how are we going to deal with these green crabs in our estuaries.
So, European green crab. It's one of the most invasive and most damaging marine species in the world. In Maine, it collapsed the soft-shell clam industry back in the 1960s.
The crabs invaded America from Europe, first coming here in the early 1800s. Their population over time stabilized between New Jersey and Nova Scotia.
In 1980, though, crab populations started to move a lot. And initially people thought climate change, right? But it's not.
A researcher in 2006 discovered that southern crabs came from southern Europe, where the waters are warmer, and the crabs found in Newfoundland came from northern Europe.
And so this points to two separate invasion instances rather than just one. And his hypothesis was that the crab from the north are much more cold tolerant than those from the south. And what I've been doing is I've been trying to find a specific genetic linkage. So essentially finding a specific gene and saying this gene is partially responsible for cold tolerance.
Those two different populations essentially are expanding as the climate is changing. One is moving a bit more southward, one is moving a bit more northward. And if we know something about the genetic properties of those crabs, we're in a better position to predict how that invasion will continue.
To try to find a link between genes and behavior, Aidan first had to test crabs' cold tolerance. The crabs he tested were collected from 3 different sites: Harpswell, Kent Island, and Nova Scotia, where the water goes from relatively warm to relatively cold for a crab.
Come on, baby. So here we have a crab.
To test the crab's cold tolerance, he put them in cold water about 40 degrees Fahrenheit for 5 minutes. Then he flipped them. If the crabs couldn't right themselves within 2 minutes, they had become too incapacitated by the cold. If they could flip, Aidan determined they were cold tolerant.
Yeah, my northern crabs flipped really well, like just super, super well.
Yeah.
And my southern crabs flipped still about 60-70% of the time, but not quite as much as my northern crabs.
Okay.
And so clearly there's some kind of difference going on.
Next he had to do some genetic work to see if he could identify the gene determining whether a crab thrived in cold water and could right itself when flipped. And he found something very interesting. He looked at 2 different parts of the genome as well as at a small section of the mitochondria.
And mitochondria provide all the energy that a cell needs to carry out its basic functions. So they're an energy generating device, you might say.
After analyzing all his data, it appeared that the mitochondrial genes were linked to a crab's cold tolerance rather than the 2 other nuclear genes he tested.
There aren't really any marine organisms that are known to have impact in mitochondria causing a change in fitness.
But here we found it in this green crab system. And not only that, we found it in a system where people are really interested in the invasion dynamics, so it translates kind of to a question that people want the answer to. It's not just basic research anymore. So
I think crabs are just pretty fascinating creatures. So they don't qualify as like the charismatic megafauna that dolphins and whales do, but they're also, they're more interesting in the analogy. They're a really dynamic species, and they're just really cool. I don't know, I love them.